Hello all, today's lecture is on computer networks. A computer network is an interconnected connection of autonomous computers. The most popular example of a computer network is Internet, wherein a number of computers are connected through the network. An example of a network is, for example, a computer, a printer, again a computer, which are also called as node, are connected through a hub, bridge and the routers to the internet. The advantages of a computer network. Computer networks allow for file sharing, resource sharing, increased storage capacity, increased cost efficiency. File sharing allows a number of files to be shared between different computers, which is possible through a computer network. Increased storage capacity. A computer network also allows increased storage capacity, where you do not have to store all the files on a single computer. The files could be distributedly stored on different computers. The disadvantages of computer networks: security issues, rapid spread of computer viruses, expensive setup, dependency on the main file server. Security issues. When you are sharing different files on a computer network, it may be that an invader attacks upon your networks and takes the file. Rapid spread of computer viruses. Sharing of files also allows sharing of viruses. That is how the virus is spread on different computers. Expensive setup. The routers, bridge, hubs, the different interconnected devices that are used in a computer network makes the network very expensive. Dependency on the main file server. Now, the most common types of computer networks are personal area network, local area network, metropolitan area network and a wide area network. Personal area network. Personal area network is a small network. For example, when your PC is connected to your printer, it forms a small network, or via a Bluetooth you are connecting your laptop with some other device in a single room. That kind of a network is called a personal area network. Its range is only for a few meters. Local area network. When you are interconnecting computer devices, usually within an office building or at home, this forms a LAN. LAN enables the sharing of resources such as file or hardware devices that may be needed by multiple users. Its size is limited. It has cost lower compared to MAN and WAN. MAN stands for Metropolitan Area Network. When you are communicating through devices or a number of devices are interconnected and of nearby corporate offices, it forms a metropolitan area network. A metropolitan area network usually connects a number of LAN, giving it a higher capacity. Wide area network. A wide area network spans over a large geographical area, for example, a country or a complete continent. WANs are used to connect LANs and other types of networks together so that the users and computers in one location can communicate with others. Now, the way the different computers are connected forms the topologies. There are different kinds of topologies in a network. The example is bus topology, where each node is connected in a row. The nodes communicate with each other along the same path, and this path forms the backbone of the network. There is also a ring topology, where the computer devices are connected in the form of a ring, and the interconnection between those computer networks is formed by a backbone. The node that wants to communicate in this sort of a network has a token, and the node that possesses the token is the one that is transmitting or receiving. Star topology. Star topology is a kind of topology in which the computer devices are connected to a single computer, or also called as a router or hub, or also a network switch. The computer devices which wants to communicate with each other sends the information to the hub, which then further transmits the information to the receiver.
Protocol. Protocols are the set of rules that are required for communication. When two entities needs to communicate, we require a protocol. When the communication is not simple, we divide our communication into various layers. These are the layers that we need to understand. For example, Maria and Anne are the two neighbors that want to communicate. Maria speaks only Spanish and Anne speaks only English. Since both have learned the sign languages in their childhood, and they enjoy meeting in a cafe a couple of days per week and enjoy their ideas using signs. Occasionally, they also use a bilingual dictionary. And communication is a face-to-face activity and happens in one layer. And this is shown that Maria and Anne communicate through the signs. Now assume that Anne has to move to another town because of her job. Before she moves, the two meet for the last time in the same cafe. Although both are sad, Maria surprises Anne when she opens a packet that contains two small machines. The first machine can scan and transform a letter in English to a secret code, or vice versa. The other machine can scan and translate a letter in Spanish to the same secret code, or vice versa. Anne takes the first machine and Maria keeps the second one. The two friends can still communicate using the secret code. This is as shown. So now this is the communication that Maria and Anne are doing, and these communications are divided into various layers. This is called a protocol. The ISO model. That ISO model is established in 1947. The ISO stands for International Standard of Organization. This is a multinational body that is dedicated to worldwide agreement on international standard. An ISO standard that covers all aspects of network communication is the open system interconnection. It is called open system because the system is open for communication for all. It was first introduced in the late 1970s. The OSI model has 7 layers. The layer 1 is our physical layer, layer 2 is data link layer, layer 3 is network layer, layer 4 is transport layer, layer 5 is session, layer 6 is presentation, and layer 7 is application layer. How this communication is being done through OSI model between two senders and receivers. First, the sender wants to send some data to some receiver. First, the first layer through which the data goes is the application layer. At each layer, we are adding some headers. This is the header that is put at the layer 7. Then we put the header at level 6. Then we put header at level 5. Then we put header at 4. But at data link layer, we add tail also, so that we can correct the error that can be in transmission of data. And when the data communication takes place through a transmission medium, and that transmission medium takes place with the help of physical layer communication with the physical layer communication of the receiver. When the data finally goes to the receiver, it goes to the elimination of that headers that we put in the case of the sender. First layer is our header, physical layer. In physical layer, physical layer is responsible for the movement of individual bits from one hop to the next, and the data transfer that takes place in the form of a bits that is shown. Physical layer is concerned with the following. It deals with the physical characteristic of interfaces and medium. It concerned with the representation of bit. It concerned with the data rate, that is transmission rate, and concerned with the synchronization of bits, line configuration, physical topology, and the transmission mode. Next layer is the data link layer, and the data link layer is responsible for moving the frames from one hop to the next. And in case of data link layer, we add header and tail to our data layer. Data link layer is responsible for doing framing, physical addressing, flow control, and error control and access control. In case of network layer, the network layer is responsible for the delivery of individual packets from the source host to the destination host. In network layer, we do the logical addressing or routing. Next layer is the transport layer. The transport layer is responsible for the delivery of message from one process to the another. This is our transport layer. Transport layer is responsible for process-to-process reliable delivery. Transport layer deals with the flow control, error control, connection control. These all are with respect to the process-to-process. Next layer is the session layer. Session layer is responsible for dialog control and synchronization. Next is the presentation layer. The presentation layer is responsible for translation, compression, and encryption. Next is the application layer. The application layer is responsible for providing the services to the user. And the major duties of the application layers are network virtual terminal, file transfer, access and management, mail services, and directory services. Thank you.